Today's point, the essential question, how do we write an equation of a graph without using a table? The topic is still equations and graphs. Today is 10-1.
That y is supposed to be.
So let's remember y equals mx plus b. And this m position is where we get the slope, but we've been learning that it's a rate of the change in the y coordinates divided by change in the x coordinates. We're also going to see this as from a graph. It's how much we move up or down depending on, like, to get from one point to another point. We're either going to move up or we're going to move down. And then the difference in the x coordinates, that's when we are moving right and left. Most of you are probably used to rise over run.
Yeah.
But we're not going to do that today because sometimes we fall. That's why I don't like rise over run, because sometimes we fall and that's a negative direction. So the B position is the y-intercept position. The y-intercept, if we were to plug a 0 in for the x-coordinate, so let's make sense of this. If we had a 0 in for the x-coordinate, anything times 0, no matter what the slope is, if it's multiplied by 0, that expression or that little term goes away. So then if we add b more, we're just left with whatever that number is. So wherever we cross the y-axis is going to be in our magic number position. These are not the same ones as your notes. So this is why I wanted this new line in color between 0, 4, and 2, 2. So if you drew it in regular pencil, then highlight this one, this new one. So that way when we do notes, you know for sure this is the new one. Okay. When we do y equals mx plus b, we've got to figure out, okay, how do I move? What is the change in the y coordinates compared to the change in the x coordinates? Meaning, how much do we move up or down? And how much do we move right or left? What we're going to do is systematically always choose the left point. So we're going to start at 0, 4 and only move on the grid. So we're not going to move diagonal to the other point. We're going to move on the grid. You could either move down and to the right, or you could move right and down. But either way, you're moving down at some point. Whenever we move down, we represent that with a negative symbol. So if I move down, I'm going to move -2. And then I moved right. No matter which way I go, I moved right to, which is a positive direction. Our rate is now becoming -2 divided by +2. We're looking at y equals -1x, but then we have to say plus, we called it magic number last week, but now we're realizing it's wherever we cross the y-axis, the y-intercept. So because we're crossing at 4, and it clearly crosses at 4, then that 4 becomes our magic number, and we've got the equation of our line. New line, again, different from what you had. I'm going to start at the left point and try to figure out how do I move to get to the point on the right. Again, I have two options. I either move up immediately and then to the right, or I move right immediately and then moving up. Either way, I move up 2 and to the right 6. So the change in the y is how much you moved up or down.
It's 1/3.
And then we've got to reduce it. So 2, 6 reduces to 1/3. Right now we have y equals 1/3 x, and we've got to figure out, well, what is the magic number? But now we know that the magic number is where we cross the y-axis. So at 0, 2 is where it's crossing the y-axis, so 2 is that magic number position.
Next problem.
Oh, these have all been.
So if I start at -1, 4 and move to the next point, whether I choose to move to the right first or down first, I'm still going to be moving in the similar direction. So I move down 5, and that's a negative direction. Right 2, which is a positive direction. So I fell 5, moved to the right 2. So our equation, that fraction's not going to reduce. We've got to figure out to the best of our ability where that magic number lies. We've got this stipulation or the speculation of 1.5, but what we're going to do is check it. Whenever so this point is -1, 4. So if I put -1 in for x, it should equal 4. So let's get out a calculator and test this. From the point, if you plug in a -1 and you simplify that expression and you get that y coordinate that it's paired with, that's how you know your equation works. So now we know y equals -5/2 x plus 1.5 because it was a speculation. Maybe it was it, and now we know for sure it's 1.5 was the y-intercept. So we actually have the same graph as each other. So the slope becomes 1/4. At this point, we have y equals 1/4 x. We've got to figure out the magic number, and you can take a guess. We're going to check and see if 4.5 actually works. So let's use this point, -2, 4. If I plug in -2, it should spit out a 4. We've got to check it. This is it. 4.5 does check out. So you've got to figure out the slope. How much do you move up or down?
0.
So I move none up or down. I do move 5 right. If I can't remember whether this is 0, whether this is undefined, the calculator can check that for you. So if you take 0 divided by 5. So y equals 0x and then the y-intercept. So y equals 0x plus 1 is one of our options. Y equals 1 is another option. Because if you take 0 times any number, it's still going to be 0 plus 1. We get back to 1 every single time. If I ever see an equation that says y equals a number, that means the y coordinates are all that number. Every single point would have comma 1, comma 1, comma 1. If we see x equals 5, so if I ever see x equals 5, all of the x coordinates are 5. So no matter, if I drew a table of what I was looking at, I'd say like, I'd have 5s written down on the entire x column and then different y values on the right column. If I connect those, what would it make? It would create a vertical line.